Good morning, everyone. This is Dr. Fatima, and today I am welcome you all for this practical session on the morphological and microscopical evaluation of Ocimum sanctum Linn leaves. It is commonly known as Tulsi. In this session, we will explore its important morphological features and microscopic characteristics which are essential for the authentic identification, anatomical study, and pharmacognostic evaluation. Let us begin with the botanical identity of Tulsi. Ocimum sanctum Linn, also commonly referred to as Ocimum Tenuiflorum. It belongs to the family Lamiaceae and also known as Lapite. It is widely known as several common names including holy basil, sacred basil, saruza, Kali Tulsi, Rama Tulsi, and Krishna Tulsi. Pharmacognostically, the drug consists of fresh and dried leaves of the plant. Now let us examine the macroscopic or morphological characteristics of the Tulsi leaf. The leaf is simple and petiolate with an opposite and discused arrangement. Its shape is generally ovate to elliptic, measuring about 2 to 5 centimeters in length and 1 to 3 centimeters in width. And the size may vary. The apex is acute to obtuse, which is base cunate to rounded and may be slightly asymmetric. The margin is serrate. The color ranges from green to purplish green. Depending on the variety, the surface is hairy, which is a reticulate veination. Finally, the leaf has the strongly aromatic odor, which is an important identifying characteristics. Moving on to the major chemical constituents of the Tulsi, the plant contains several important classes of phytoconstituents which contribute to its pharmacological properties. The volatile oil contains compounds such as eugenol, methyl eugenol, beta-caryophyllene, caravol, and linolol which contribute its characteristic aroma and various biological activities. Tulsi also contains phenolic compounds, particularly rosmarinic acid and caffeic acid, known for these antioxidant properties. Among the triterpenoids, urosolic acid and olenolic acid are important constituents associated with the antioxidant and anti-inflammatory activities. Finally, the important flavonoids, including ornithine and vicinin, are also present. Together, these bioactive constituents contribute to the diverse pharmacological potential of Tulsi. Now coming to the medicinal values of the Tulsi, it has been traditionally used for its antimicrobial, anti-inflammatory and antioxidant and adaptogenic properties. It is commonly used to support the management of cough, cold and respiratory discomfort and mild digestive complaints. Its phytoconstituents also contribute to its immunomodulatory and hepatoproductive activities, making Tulsi is an important medicinal plant in traditional healthcare. Before beginning the microscopic evaluation, let us identify the experimental materials required. The setup includes the Tulsi leaves, glass slides, cover slips, a blade, needle, brush and dropper, watch glass, petri dishes, water, glycerin, dilute hydrochloric acid, iodine, concentrated hydrochloric acid and fluoroglucinol along with the microscope for observation. In this step, a fresh potato is carefully selected and cut into a small thin piece using a clean blade. Care should be taken while handling the blade and preparing the specimen for the next step of the experiment. This is to insert the leaf for the sectioning purpose. A fresh and healthy Tulsi leaf is carefully selected and placed on the suitable potato piece for sectioning. The leaf is positioned firmly to obtain thin and uniform sections. Using sharp blade, the leaf is carefully sectioned for further microscopic examination of its internal and anatomical features. Now let us perform the microscopical evaluation of Tulsi leaf step by step. First, select fresh and healthy Tulsi leaf and gently clean it to remove and any surface dust or impurities. For preparing the transverse section, the leaf is carefully inserted into a small piece of potato which acts as a supporting material and helps in the obtaining thin and uniform section. Using short blade, make several thin transverse section of the leaf. The section should be a thin possible because a very thick section will not allow clear observation of the internal tissues under the microscope. Transfer these sections gently into a watch glass containing water. From these sections, select the thinnest and most complete section for the mounting. Depending on the staining procedure, the section will be treated with the required reagent. For demonstrating lignified tissues, fluoroglucinol followed by the concentrated HCl is used. The development of characteristic color helps in identifying lignified elements. After staining, add a drop of glycerin to the section and carefully place the cover slip over it. Avoid trapping air bubbles while placing the cover slip. The prepared slide is now ready for the microscopic examination. First, observe the specimen under the low power objective to locate and examine the overall anatomical structure. Then shift into the high power objective to study individual tissues in greater detail. During observation, pay attention to the upper and lower epidermis, mesophyll, vascular bundles, stomata, trichomes, and other diagnostic anatomical feature of the Tulsi leaf. Now let us examine the diagnostic microscopical characters of the Tulsi leaf under the microscope. Starting with the transverse section or TS of the leaf, we can observe a typical torsventral arrangement. The upper epidermis consists of a single layer of cells which are generally rectangular to polygonal in shape with slightly wavy anticlinical walls. The upper epidermis is the Palisade tissue followed by the loosely arranged spongy parenchyma. In the central region, we can observe the vascular bundle. It is a collateral vascular bundle and it is surrounded by a parenchyma bundle sheath. The lower epidermis consists of irregular shaped cells with wavy walls. Now looking at the epidermal surface views, both upper and lower epidermis show stomata. The stomata are generally anomocytic in type and are oval to elliptical in appearance. The lower epidermis usually shows the greater number of stomata. Another important diagnostic feature is the presence of trichomes or epidermal hairs. Tulsi leaf shows different types of trichomes including unicellular covering trichomes, multicellular trichomes, and glandular trichomes. These structures are particularly important for the identification and authentication of the leaf. The glandular trichomes are associated with the secretion and storage of volatile constituents, contributing to the characteristic aromatic nature of Tulsi. Finally, the prismatic calcium oxalate crystals be observed within the mesophyll. Therefore, the major identifying microscopical features of the Tulsi leaf are anomocytic stomata, different types of trichomes, collateral vascular bundles, and prismatic calcium oxalate crystals. Together, these characters provide valuable evidence for the pharmacognostic identification, evaluation, and authentication of the Tulsi leaves. So, I hope you all have understood the morphological and microscopical evaluation of Tulsi leaves and the important diagnostic characters used for their identification and authentication. Thank you for watching and I hope you found this session informative and useful. See you in the next session. Thank you so much.